We're talking about transforming functions today. So remember those parent functions that we looked at? Well, we can take those parent functions and we can move them side to side, up and down. We can squish them, we can stretch them. We can do lots of different things to them that help us see different graphs besides just the parent function. So what do these transformations look like and how do we actually do them? So I'm going to just show you a general example. This is not a parent function, this is just some random function. And we're going to see what happens when we do each of these things to the parent, or to this parent function. Okay, so the first thing I want you to recognize is whether something is inside the function or outside the function. And when I say inside the function, what I mean is whatever we do to x, we also do to that number. For example, something that would be inside the function would be x plus 2 squared. So squaring something is a function. It does something to the x, right? It multiplies it by itself. And so when I put 2 inside, it's also this x plus 2 as a whole is getting squared, not just the x, right? So this 2 is now inside the function. But if I did x squared plus 2, do you see how the 2 is outside? The 2 is not getting squared with the x. It's outside the function. So this one is outside the function, this one is inside the function. Let's look at another example of that. If I had the absolute value of x plus 3, or the absolute value of x plus 3, do you see that the function is the absolute value function? The function is something that's doing something to x. And in this case, the 3 is outside the function, and in this case, 3 is inside the function. So the 3 is also getting absolute valued, whereas on this one, the 3 is not getting absolute valued. Okay, one more example. This one's a little harder to see. What about the function 1 over x? That's a parent function of ours. And how would it look like if something was inside the function? Well, it would look like, this. It's also in the denominator, right? The 3 is also being divided, just like the x is. Outside the function for this one would look like this. 1 over x plus 3. You see how the 3 is not doing the same thing as the x? So the very first question we always ask when we see a transformation of any sort is we say, okay, is this number inside the function or outside the function? And that tells us what it does to the function. So first, if we see a number outside the function like this, and we're just adding it to the function, when you see something outside the function, it's going to only affect the y values, okay? Because inside the function is x values, outside the function is y values. So anything outside the function doesn't change our x values at all. It does nothing to our x values. All it does is mess with our y values, okay? So this is going to mess with y. This is going to mess with x because this is outside, this is inside, okay? So how do we look at this? If I said, here's my function, my yellow function, right? It's f of x plus 2. When anything is outside the function, we're going to mess with our y values. And what I want you to remember is that your x is a liar, okay? So when we're doing something to x, when we're messing with x values, x lies. So it's going to do something that's opposite of what you would think it would do. So if it's adding, it's actually going to subtract. Y does not lie, okay? Your x is a liar, but y does not lie. So for y, if we see the function plus 2, literally all it does is take all of your y values and add 2 to them. So let's see what that looks like. So if I took this first point that's right here, and I move it up to 1, 2, it's going to go here, right? All I did is add 2 to that y value. I just pushed it up 2. Same with this one. I move it up to 1, 2. And then this point, 1, 2. 1, 2. I just move all of those points up, and then I just draw the function just like it was before. It's just moved up 2. See how I just literally copied and pasted it up 2. I didn't stretch it. I didn't push it in. I didn't do anything weird like that. All I did was pick it up and move it. So this is called a translation. You don't have to know the name for it, but basically it's a vertical translation, which it goes up or down. Now, if this was f of x minus 2, we would do the same thing, except for instead of adding 2, we're going to subtract 2 because y doesn't lie. So we're going to go down 2. And we're going to have this function right here. Okay, again, we copied and pasted. The shape of the function didn't change at all. All we did was pick it up and move it up, or pick it up and move it down. Okay, so then what do you think would happen if we add or subtract from the x's? So when we add and subtract from the y's, it either adds to the y's or subtracts from the y's, right? So if we add to the x's or subtract to the x's, it should move left and right. It should just move them over, right? So remember, x is a liar. So if we see something like f of x plus 2, what we know is that x lies, and so it looks like we're adding 2 to all the x's, but we don't. We actually subtract 2. And there's a long mathy explanation for it. I'm not going to get you hung up on that, but basically just remember that x lies. So we're going to go, instead of moving to the right 2, I should turn this way because my camera's on. My camera is mirrored. To the right 2, we're going to move to the left 2. Okay? So, I take all of my points and I just move them over 2. This one goes over here. This one goes there. This one goes there. And this one goes there. So do you see how I took the original function? Again, I didn't change the shape at all. All I did was I picked the function up and I moved it on the graph, okay? And since x lies, the plus 2 actually subtracted 2 from each of my x's. Okay, same thing on this one, but remember x lies. So if I see something that's like f of x minus 2, I think, ooh, x is a liar, so x is telling me subtract 2, and I say, nope, I'm adding 2, okay? So I'm going to add 2 to each of my x values. So this point right here, when I add 2 to it, it moves over in the positive direction, 2. So when I take this x right here, I move it over 1, 2, and it goes right here. I move that one over, move that one over, that one. Oop, I accidentally forgot. Oh, wait, there we go. I don't need to. I got confused by that one right there. There we go. All we do is we move it over 2. Do you see how we're just shifting it? So again, when we're adding and subtracting, outside the function moves it up and down. Inside the function moves it left and right. So what happens if I have a negative outside the function or if I have a negative inside the function? So let's see. This says, since it's outside the function, it's doing something to the y values. And what it says is, hey, take all my y values and multiply them by -1, which just really changes their sign, right? That's all it does, is it changes them from positive to negative or negative to positive. But all we do is multiply them by -1. So since y doesn't lie, we're going to do exactly what it says. So the y value of this point right here is 0. So 0 times -1 is still 0. But the y value of this point right here is +1. So when I take that y value and I multiply it by -1, I end up at -1. The y value of this one is also 0, so it stays there. The y value of the next one is +1, so it becomes -1. And the y value of this one is -2. This one right here is -2, so where do you think it goes? Well, when I multiply -2 by -1, it actually goes up, right? It becomes +2. So now we can graph this just like that. Do you see what happened there? What it does is it actually reflects it across the x-axis. Just reflects it across the x-axis. All right. Now what happens if it is on the other on the inside of the function, okay? So what this says right now is, hey, I want to multiply all of my x values by -1. But you remember that we do the opposite if it's inside. So instead of multiplying by -1, we divide by -1. But guess what? Dividing by -1 is the same as multiplying by -1. So this is like the one time where x kind of does something that you would think it does, okay? So what this is saying is take all of my x values, and I'm going to divide them all by -1, so that's going to change their signs, right? So let's start with this one. This has an x value of -1, 2, 3, 4. -4. So when I divide that by -1, it becomes +4. 1, 2, 3, 4. So we're going to do that one right here. Okay? Now this one has the next one has an x value of -2. So where that one is going to, when we divide that by -1, it's going to become +2. This one right here is right at the origin. It has a y value or an x value of 0. So it, when you divide that by -1, stays 0. This one has an x value of +1. So when we divide that by -1, it's going to become -1. And this one has an x value of +3. So when we divide that, it's going to become -3. So here we go. Do you see what happened there? It actually reflected across the y-axis. So we reflected that one across the y-axis. All it did is change the sign of all the x's. Okay. Next, what happens when we have an a on the outside of the function, or a number on the outside of the function? Well, again, remember, since this is outside the function, it only messes with the y's. And because y doesn't lie, if there's a number out here, we're just going to do whatever that number says to do. Okay, so if I have 2 times my function, then what I'm going to do is all of my y values, I'm going to multiply them by 2. Okay, so this function, the y value right here is 0. So 2 times 0 is still 0. But this one, the y value is 1. So I multiply that by 2 and it goes to here, right? My x values don't change, right? Because I only have something inside the function. I don't have something outside the function. What about right here? My y value is 0, so I still get 0. My y value here is 1, so I multiply that and I get 2. My y value here is -2, so I actually multiply that by 2 and I get -4. So do you see that when I do that, it actually stretches it? It's like you took something and you just pulled it up like those old torture machines. Okay? The x values didn't change. All that happened is all the y values get multiplied by 2. What happens if that y value is like a fraction, if that a value is a fraction? So we have 1/2 times f of x. Well, since y doesn't lie, all we do is multiply by 1/2, right? And remember that multiplying by 1/2 is really just dividing by 2. So we take all of our y values and we divide them by 2. So 0 divided by 2 is still 0. 1 divided by 2 or multiplied by 1/2 is just 1/2. 0 is 0. 1 is 1/2. Now this is 2. Half of 2 is 1. So my new function is this little squishy thing. So this is a vertical compression. So I just squished it in until it just like was short and fat. Okay? I didn't just fat shame the function. Last but not least, I'm going to show you what happens when we have a number multiplied inside the function. Now I'll tell you, in Algebra 2 we don't see this very often. We usually see this mostly in pre-calculus. So if it's a little bit over your head, that's totally fine if you're in Algebra 2. But I want to show you what it looks like. So if I have a number inside the function, what it does is the opposite of what it looks like, right? So this tells me, hey, multiply all your x values by 2. And I go, nope. X is a liar, so I'm not going to multiply all my x values by 2. I'm going to divide them by 2. I'm going to do the opposite. So this function, this point right here is normally at -4, so I divide it by 2, and shoop, it's at 2. This one's normally at 2. I divide it by 2, it goes here to 1 to 1. This one's at 1, so I divide it by 2, it becomes 1/2. This one's at 3, and I divide it by 2, it becomes 1.5. And so all I did is do a horizontal compression. I squished it in. All right, so that's really what compression means, is I squish it. Now, if you look at this other one, this one is, if instead of being a 2, this is a 1/2 inside. Remember, I do the opposite of what it looks like. So it says multiply all your x values by 1/2, and I say, nope, I'm going to divide them all by 1/2, which is really multiplying by 2. So I take this number, I multiply it by 2, I take that, I multiply it by 2, I take that one, I multiply it by 2, and that's